You've found Dreamtime Science, part classroom, part lullaby, entirely devoted to satisfying your curiosity while you find your way to sleep. You know what's fascinating? I've been thinking about how the James Webb Space Telescope is like a time machine, peering back to the very first stars and galaxies that ever existed. There's something remarkable about how it uses its giant golden mirrors to capture light that's traveled billions of years, almost like listening to whispered stories from the dawn of the universe. I'm really excited to share how this incredible telescope helps us understand where we came from, all while floating quietly in the cold darkness of space. If this peaceful blend of science and serenity helps ease your evening, consider joining our community of gentle learners. Share your favorite moment of scientific awe in the comments. Now, take a moment. Adjust your blanket, find the perfect hollow in your pillow, let your shoulders melt, breathe in and out. There are some evenings when the sky looks so clear, so brushed with velvet indigo and distant flashes of silver, that it is easy to believe the universe is watching back. On such a night, the mind reaches for stories of gods and monsters, explorers and eyes that never close. For centuries we have gazed upward with longing, our curiosity stretching as far as our myths could carry it. We drew constellations, told tales of heroes pinned to the firmament, and in the flickering glow of campfires we wondered if anything was out there watching us in return. Now, in the quiet luminescence of the 21st century, we have sent our own gaze out into the darkness. Not an eye of flesh and bone, but one of gold and glass, cold metal and meticulous calculation. Suspended 1,000,000 miles from Earth, the James Webb Space Telescope unfurls its petals to the cosmos, an instrument of wonder and a mirror to our yearning. It is not just a tool, it is a new myth, woven from the threads of science and imagination. When the first images from Webb burst onto the world stage, they did not just reveal nebulae and galaxies. They awakened something older, a sense of awe so profound it is almost religious. Art, literature and film have always borrowed from the heavens, and the Webb itself, with its grand hexagonal mirror of gold segments, has become a cultural symbol faster than any telescope before it. Children peer at its shimmering likeness and see the eye of a dragon or the window to another world. Artists paint it as an interstellar flower blooming against the darkness. And those steeped in the tales of Middle-earth see unmistakably the fiery gaze of Sauron, the unblinking, all-seeing eye. This comparison is no accident. There is something haunting and majestic in the way Webb's primary mirror glows, sharp-edged and symmetrical, as if it were both a thing of nature and of uncanny design. Yet the eye of Sauron, imagined by Tolkien, was a symbol of malice and relentless pursuit, a gaze that scoured the world for secrets, leaving nowhere to hide. The Webb, in contrast, is a gentler sentinel. It does not seek to possess or to dominate, but to reveal, to see, not to command. Still, the resonance between the imagined and the real is strong. Both eyes, one fictional, one technological, are portals, thresholds between the known and the unknown. Consider the design of Webb's mirror, 18 hexagons, each coated in a whisper-thin layer of gold, arranged in a honeycomb so precise that a shift of a human hair's breadth would upset the entire image. From a distance the mirror gleams like a shield from myth, or a fragment of celestial armor. Yet its purpose is not defense, but discovery. Each segment can be adjusted with uncanny precision, focusing the faintest rays of ancient light into patterns that only mathematics can decode. The mirror itself is vast, over 6.5 meters across, dwarfing its predecessors. Compared to the circular eye of the Hubble Space Telescope, Webb's mirror appears almost alien in its geometry. The hexagons fit together without a gap, like the cells of a beehive or the scales on a dragon's back, and the gold, That is not an accident of aesthetic, but a choice rooted in physics. Gold is supremely efficient at reflecting infrared light, the kind of light that Webb is built to see, the kind that slips through cosmic dust and carries the secrets of the coldest, oldest corners of the universe. When Webb first unfurled its mirror in the vacuum of space, the world watched with bated breath. For this was not a simple act of engineering, but a choreography more delicate than any ballet. The mirror had folded into the body of the telescope for its launch, a flower bud waiting to bloom. If even one hinge had faltered, one segment stuck, the entire mission could have ended in silence. But the petals opened, gold catching the sunlight, and the telescope became what it was meant to be, a cosmic mirror reflecting light that has journeyed for billions of years. It is easy, then, to see why the Webb has captured the cultural imagination. We crave eyes that can see further than our own. In science fiction, the dream of a perfect, unblinking gaze is as old as the genre. There are orbs of prophecy, windows to other dimensions, machines that peer through time. Webb, in its golden armor, seems to fulfill these fantasies, straddling the line between science and sorcery. Yet for all its majesty, there is a persistent myth that must be gently dispelled, a myth as alluring as the stories that gave Webb its symbolic power. Some say with certainty that Webb does not merely look far, it looks back, piercing the veil of time itself to witness the distant past. That it is, in effect, a time machine, a magical eye, peering directly into bygone epochs. But this is not quite true. Webb is not a window into the past in the sense of a fantasy portal. There is no direct viewing of ancient scenes, no cosmic cinema where we watch the birth of stars in real time. What Webb does, what all telescopes do really, is capture light that has travelled for immense distances. And since the universe is so vast and light so patient, the photons that reach Webb's mirror have been travelling for billions of years. When we look at a star 1,000 light years away, we are seeing it as it was 1,000 years ago, because that is how long its light took to reach us. Webb's true magic is not in bending time, but in taking advantage of the universe's own inertia. All telescopes are time machines in this indirect way, but Webb is built to see light so ancient, so stretched by the expanding universe, that it gives us glimpses of the cosmos as it once was, when stars were young and galaxies unformed. To look with Webb is to look into the deep, deep past, but only because the present is stitched together from light that has taken eons to arrive. There is no telescope, no matter how mighty, that can reach through time like a sorcerer's spell. There is only light and patience and the careful gathering of ancient signals. Webb's mirror does not show us the past as it happened, but as it was imprinted on the photons that have wandered across the darkness, bearing the faintest memories of creation. Consider the analogy of a distant thunderstorm. You see the flash of lightning, and several moments later you hear the thunder. The sound travels more slowly than the light, so you are always experiencing the storm in layers, first the sight, then the sound, each arriving at its own pace. With Webb, it is as if we are seeing the lightning of events that happened billions of years ago, the light finally reaching us after its long, tireless journey. But the storm itself is long past. We are only now catching up to its echoes. This subtle distinction is important, for it grounds the magic of Webb in the real and makes its achievements no less wondrous. The telescope's mirror is not a magic eye, but an exquisite tool tuned to the faintest whispers of the universe. It allows us to assemble the story of the cosmos, page by page, photon by photon, reconstructing what once was from the light that remains. And so, when people compare Webb to the eye of Sauron, they are half right and half wrong. Like Sauron's eye, Webb's mirror is unblinking, inexorable, capable of seeing what was once hidden. But unlike the eye of Tolkien's Dark Lord, Webb does not see the present with a malice or intention. It works with the relics of the past, not the events unfolding now. Its power is not one of domination, but of discovery. The stories we tell about Webb, the myths we weave around its golden petals, reveal as much about us as about the telescope itself. We want to believe in eyes that can see all, that can pierce not just space, but time. We long for certainty, for a gaze that cannot be evaded. Yet the truth is richer, gentler, and more profound. Webb's mirror is a marvel not because it is omniscient, but because it is exquisitely sensitive, able to gather the faintest embers of ancient fires, to assemble a tapestry of light from threads almost lost in darkness. The cultural power of Webb lies in its ambiguity, its liminality. It is both science and symbol, both eye and mirror. It reflects not only the universe, but our own longing to understand. The honeycomb mirror is a technological marvel, yes, but it is also an artifact of our collective imagination, a sign that we are always reaching, always dreaming, always building eyes to see what lies beyond. As you drift deeper into the gentle dark, picture Webb suspended in the cold silence between worlds. Its mirror catches the faint, invisible glow of galaxies being born, of stars dying, of dust clouds swirling in gravity's embrace. It is silent, patient, waiting for the next photon to arrive. Somewhere, the mirror gleams gold against the endless black, an improbable blossom floating in the void, poised between what is and what was. People will continue to tell stories about Webb, to paint it as the eye of a god or the key to another reality. They will dream, as they have always dreamed, of eyes that see everything. And yet, the telescope itself remains indifferent, devoted only to the gathering of light, the quiet reveal of hidden things. Its power lies not in its resemblance to myth, but in its ability to test those myths, to bring back news from the darkness, to show us what the universe is willing to reveal. And so the golden mirror turns, and the universe waits. The sky is vast and full of secrets. The next act of this cosmic story is already unfolding, written in the light that is only now arriving. The mirror, patient and unblinking, stands ready to receive it, to turn the unknown into a new kind of knowing. The journey has only just begun, and the darkness is full of promise. In the cool, measured silence beyond our turbulent blue world, the James Webb Space Telescope drifts, a sentinel poised at the threshold between darkness and revelation. It is a machine born from centuries of yearning and decades of painstaking labor, existing now at a place known as the second Lagrange point, 1.5 million kilometers from Earth. Here, in this delicate gravitational balance, Webb is shielded from the warmth and glare of our planet and sun, cocooned by its golden mirrors and an immense sun shield, the better to listen for the faintest whispers of the ancient cosmos. But before Webb could gaze into primordial night, it lived for many years only as dream and blueprint, a puzzle made of ambition and uncertainty. In the early years of planning, the minds behind Webb grappled with questions both philosophical and fiercely technical. What would it mean to build a telescope more sensitive than any that had come before, one that could see not just the stars, but the very first light kindled in the universe, billions of years ago? How could they create an observatory so powerful that it could peer through curtains of cosmic dust, reading the signatures of molecules swirling in the atmospheres of distant exoplanets? The challenges were almost mythic in their scale, and yet they were tackled one by one with both anxiety and awe. The most iconic and demanding feature of Webb is its primary mirror, a gleaming segmented eye, 6.5 meters across, sheathed in gold, and as delicate as it is vast. Unlike Hubble, whose single circular mirror was a monolith, Webb's main mirror is a mosaic of 18 hexagonal segments, each carved with nanoscopic precision, each able to move by fractions of a human hair's breadth. This was not mere engineering, it was choreography, a ballet of alignment and calibration performed in the freezing vacuum of space. To understand why such complexity was necessary, we must look not only at the telescope's ambition, but at the nature of the universe itself. The light that reaches Webb from the infant cosmos is not the crisp white starlight that fills our skies tonight. Instead, it is stretched, pulled and reddened by the expansion of space-time itself, a phenomenon known as redshift. When an object in the universe is moving away from us, the waves of light it emits are lengthened, shifting toward the red end of the spectrum. For objects at immense distances, this effect is profound. The earliest galaxies, their ultraviolet and visible light born in the dawn of time, now arrive at Earth as faint, cold infrared. Infrared light is heat, the soft glow of warmth that lingers after a candle is snuffed out. It is invisible to our eyes, yet it is all around us, in the pulse of a star, the shimmer of a nebula, the gentle radiance of a planet's surface. To see the ancient universe, then, Webb had to become an instrument of shadows and warmth, exquisitely sensitive to the faintest ember left from creation's forge. This necessity shaped every aspect of Webb's design, and every choice led to new difficulties. Infrared detectors are like the retinas of eyes adapted for darkness. They must be kept colder than the frostiest Antarctic night, lest their own warmth overwhelm the signals they seek. To accomplish this, Webb wears a sun shield the size of a tennis court, a 5-layered membrane of silvered kapton thinner than a human hair, each layer spaced apart so that the heat from the sun is bounced and dissipated, never reaching the sensitive instruments behind. The mirror itself, for all its grandeur, is forged from beryllium, a metal both strong and light, chosen because it does not deform in the bone-chilling cold of space. The deployment of these elements, mirror, sun shield, and a nest of scientific instruments, was a feat bordering on the miraculous. Launched folded like an origami crane within the nose of an Ariane 5 rocket, Webb's journey to readiness was a ballet of unfolding and locking, of motors whirring and latches catching, each step executed remotely and without the possibility of repair. There was no room for human hands to intervene, no opportunity for a second chance if a hinge stuck or a cable snapped. The world held its breath as Webb's sunshield unfurled, petal by petal, and as each mirror segment moved into place, aligning itself so that light from the edge of the cosmos could be gathered without distortion. Within Webb's heart, 4 scientific instruments wait to receive the universe's secrets. Each is a marvel in its own right, designed to tease out different stories from the infrared tapestry. The near-infrared camera, or NIR-CAM, is the primary eye, able to image the faintest galaxies and split their light into colors to reveal their composition and age. The near-infrared spectrograph, NIR-SPEC, is a device of astonishing subtlety, able to analyze the spectra of hundreds of objects simultaneously, extracting the fingerprints of atoms and molecules from the dimmest glimmers. The mid-infrared instrument, MIRI, pushes deeper still, probing wavelengths where dust clouds glow and the building blocks of planets and life are revealed. And finally, the fine guidance sensor, paired with an imager called NIRIS, ensures that Webb can lock onto its targets with the steadiness of a mountain, holding its gaze for hours or days as it collects photons that have traveled across billions of years. But even with such tools, there are boundaries to what Webb can glimpse. The universe, for all its grandeur, is not eager to surrender its mysteries. Cosmic dust, fine grains of silicate and carbon, scattered like smoke between the stars, can obscure even the most sensitive detectors. Gravitational lensing, in which the mass of intervening galaxies bends light into arcs and halos, can distort the shapes of distant objects, making interpretation a subtle art. And always, the relentless expansion of the universe stretches light ever further, so that beyond a certain point, the glow of the first stars slips out of reach, redshifted into wavelengths too long for even Webb's keen senses. The science of redshift, then, is both a key and a limit. When astronomers measure the redshift of a galaxy, denoted by the symbol Z, they are measuring how much its light has been stretched by the expansion of space. A galaxy with a redshift of 1 has its light doubled in wavelength. A redshift of 10 means it has been stretched 11-fold. The cosmic microwave background, the afterglow of the Big Bang, is redshifted by more than 1,000, its primordial light now a faint, cold radio whisper. For Webb, the practical limit lies somewhere between redshift 10 and 20, an epoch when the first galaxies were assembling and the universe was a few 100 million years old. To reach further would require a new kind of instrument, a telescope designed for even longer wavelengths, colder detectors, and perhaps a vantage point further from the warmth of the sun. But within its domain, Webb can do what no other observatory has done. It can watch as starlight first breaks through the fog of hydrogen that filled the infant cosmos, as galaxies swirl together, as black holes ignite at the centers of nascent clusters. Yet the journey from idea to reality was never smooth. Delays accumulated as engineers discovered that no existing technology could meet the demands of the telescope's design. Detectors had to be invented that could operate at temperatures near absolute zero, processing the faintest glimmers of light without introducing their own electronic noise. Mirror segments had to be polished and coated, not just for reflectivity, but so that each one would respond identically to the frigid conditions of space. The sun shield, with its 5 gossamer layers, was tested and retested until it could be folded and unfurled without snagging or tearing, a challenge that consumed years and millions of dollars. Every problem solved revealed another waiting in the shadows. How to route power and data through a structure that changes shape as it unfolds. How to ensure that cosmic rays, high-energy particles racing through space, would not disable Webb's delicate electronics. How to communicate with a telescope that by its very distance is invisible to the naked eye and takes seconds for a signal to reach. Each answer was a triumph snatched from uncertainty, but each solution brought new constraints. Webb is not an all-seeing oracle. It is, rather, a carefully tuned instrument, exquisitely sensitive to some signals, but blind to others. It cannot observe the universe in visible or ultraviolet light. Its gaze is limited to the infrared, and even then, only within certain bands, determined by the sensitivity of its detectors and the temperature they can achieve. The sun shield, for all its ingenuity, is no match for the relentless sun if Webb's orientation drifts, and so the telescope must always keep its back turned to the solar glare, limiting which regions of the sky can be observed at any time. Then there is the matter of time itself. The components of Webb, for all their sophistication, will degrade. The detectors will accumulate radiation damage. The sun shield may suffer tiny punctures from micrometeoroids. The fuel that allows Webb to adjust its position and maintain its station at L2 will eventually run out. The telescope is, in a sense, burning its candle at both ends, racing to collect as much data as possible before its sensors begin to dim. Despite these constraints, Webb's promise is unmatched. Its ability to see through dust allows it to probe the birthplaces of stars and planets, regions obscured to Hubble and ground-based telescopes. Its spectrographs can dissect the light of exoplanet atmospheres, searching for the fingerprints of water, methane, carbon dioxide, perhaps even hints of life. And above all, its reach into the early universe is unprecedented, offering the chance to witness the assembly of the first galaxies and the transformation of cosmic chaos into order. Yet every discovery brings new puzzles. Already the images sent back by Webb have upended theories, revealing galaxies more massive and luminous than expected at epochs when the cosmos was still young. The familiar patterns of galactic evolution, drawn from decades of observation and simulation, must now be redrawn to accommodate what Webb sees. The telescope's sharp vision cuts away old certainties, replacing them with richer, more complicated realities. And so, as Webb orbits in its cold vigil, it casts light not only on the cosmic shadows beyond, but on the limits of our own understanding. Its golden mirrors reflect not just the stars, but the tangled hopes and questions of the species that built it. For every answer it provides, a dozen new mysteries are revealed, each one a shadow waiting to be chased by future explorers. In the darkness beyond the sun's reach, Webb waits, patient and unblinking. Its instruments drink in the faint warmth of creation, passing every photon for meaning. Somewhere, in the next moment of observation, the next trickle of ancient light, another secret will be drawn from the cosmic deep, a secret shaped by the limits of glass and gold, of beryllium and memory, of redshift and time. But there are still deeper mysteries to follow, and further into the infrared night Webb will peer, seeking not only the light that was, but the stories yet to unfold in the cold and silent expanse. Far from the warmth of Earth, more distant than the moon's ghostly orbit, there floats a sentinel among the shadows, a machine of gold and glass, poised at the edge of our cosmic reach. The James Webb Space Telescope, or Webb, is not merely a telescope, but a cathedral of precision and patience, waiting in the deep cold for the faintest whispers of ancient starlight. To understand Webb's wondrous ways, one must first follow the winding path that led humanity to build so audacious an instrument, and then trace the intricate clockwork of its instruments, each tuned to secrets invisible to the naked eye. The story of Webb is a tapestry of ambition, setbacks, and tenacity, woven over decades of dreaming and engineering. In the early 1990s, astronomers stood awestruck by the revelations of the Hubble Space Telescope, distant galaxies resolved, the age of the universe measured, nebulae blooming in colors undreamt of. Yet, even as Hubble peered deeper, a longing grew among the scientific community, to see farther, to look further back in time, to witness the first galaxies kindling their primordial light. But the earliest moments after the Big Bang are bathed not in visible light, but in the deep, gentle glow of infrared, a spectrum to which our eyes are blind. The universe, you see, is expanding. As galaxies hurtle away from us, the light they emit is stretched, slipping from blue and white to red, and finally into the invisible. This cosmic redshift means that the afterglow of the first stars and the fingerprints of planets circling distant suns are all written in infrared. Thus the vision for the James Webb Space Telescope, a machine not for the visible, but for the hidden warmth that shrouds the universe's earliest days. But to catch such delicate light, Webb would need to be unlike any telescope built before. Even the faintest warmth from the telescope itself would drown out the signals it sought. So it must be cold, colder than Pluto's night, colder than liquid nitrogen, chilled to just a few tens of degrees above absolute zero. Hubble orbits in the cozy embrace of Earth's shadow, but Webb would travel far beyond, to a lonely post at the second Lagrange point, or L2, some 1.5 million kilometers from home. There, with the sun and Earth always behind it, Webb could unfurl its golden mirrors and bask in deep, uninterrupted night. The journey from blueprint to launchpad was long and perilous. Webb's mirror, a gleaming honeycomb of beryllium and gold, stretches over 6 meters across, too vast to fit in any rocket's fairing. Engineers devised a marvel of folding segments, each polished finer than a snowflake, which would unfold in space with the precision of a clockmaker. Beneath the mirror, a sun shield the size of a tennis court would blossom, layer upon layer of silvered fabric, each thinner than a human hair, reflecting away the sun's fierce light and allowing the telescope to cool, to become an eye attuned to the universe's chillest embers. Within this floating observatory, 4 instruments nestle together, each one a marvel of optical engineering and scientific cunning. Tonight let us linger on 2, Webb's near-infrared camera, or NIR-CAM, and the mid-infrared instrument, or MIRI, twin keys to the secrets of stars and worlds. NIR-CAM is Webb's primary imager, the very heart of its vision. Its job is to catch light in the near-infrared from wavelengths just beyond what our eyes can see to about 5 micrometers, where warmth and darkness dance. NIR-CAM is a symphony of detectors and optics, able to capture vast, sweeping views of the sky or focus with astonishing sharpness on a single, trembling point. It is through NIR-CAM that Webb glimpses the faint glow of the first galaxies, the light that has travelled for over 13 billion years, stretched and softened by the universe's expansion. But NIR-CAM is more than a simple camera. It is an explorer of contrast and subtlety, able to peer through the dusty veils that cloak star-forming regions, revealing nurseries where new suns burst to life. In visible light, such clouds are opaque, dark lanes writhed across the sky. But in the near-infrared, NIR-CAM sees through the mist, exposing the tender filaments and cocoons where gravity gathers gas and dust into the seeds of future worlds. In these observations, astronomers can watch the drama of creation unfold, tracing the transformation of chaos into structure, of formlessness into the shining order of stars. NIR-CAM is also crucial for another of Webb's ambitions, the study of exoplanets, those far-off orbs circling other stars. To image these dim companions, often lost in the glare of their suns, NIR-CAM employs special masks called coronagraphs. Like a raised hand blocking the sun's dazzle, these devices suppress the star's light, allowing the faint glow of orbiting planets to emerge from the darkness. In these delicate images, astronomers hope to read the fingerprints of alien atmospheres, detecting the subtle colors of water vapor, methane, or perhaps even the faint blush of life. Yet as we move deeper into the infrared, to wavelengths 10 or even 20 times longer than visible light, NIR-CAM hands the baton to MIRI, the mid-infrared instrument. MIRI is, in many ways, an explorer of the coldest and oldest realms. Its detectors are chilled to just a few degrees above absolute zero, for even the faintest warmth would overwhelm the signals it seeks. MIRI opens a window onto phenomena invisible to any other eye. Where NIR-CAM might glimpse the hot heart of a newborn star, MIRI sees the cool shroud of dust and ice that swaddles it, the intricate architecture of protoplanetary disks, where new worlds are assembling grain by grain. It is in these chill domains that organic molecules, building blocks of life, form and persist. MIRI can detect the spectral fingerprints of complex hydrocarbons, water ice, and silicates, mapping the chemistry of cosmic nurseries with exquisite sensitivity. MIRI also excels at peering into the hearts of galaxies, where supermassive black holes feast and radiate, cloaked in swirling clouds of dust. The mid-infrared glow betrays the hidden drama of accretion and feedback, processes that shape the life cycle of galaxies themselves. In the glow of ancient galaxies, MIRI reads the signatures of cosmic evolution, tracing the rise and fall of star formation across billions of years. But the power of these instruments is not just in what they see, but in how they see. Both NIR-CAM and MIRI are equipped for spectroscopy, the art of breaking light into its constituent colors, revealing the fingerprints of atoms and molecules. In the spectrum of a distant exoplanet, astronomers can read the composition of its atmosphere, the presence of water, the breath of carbon dioxide, the haze of methane. Each molecule absorbs and emits light at precise wavelengths, etching a code into the starlight that passes through or reflects from the planet's air. To accomplish this, Webb uses a clever technique known as transit spectroscopy. When a planet passes in front of its star, a tiny fraction of the starlight filters through the planet's atmosphere before reaching us. By comparing the spectrum of the star with and without the planet in front, astronomers can subtract away the star's own features and isolate the delicate tracery of the planet's atmosphere. It is this method that has, even in Webb's earliest months of operation, begun to reveal the weather and chemistry of alien worlds, clouds of vapor, hints of hazes, perhaps someday the telltale signs of biology. Such experiments demand stability of the highest order. The telescope must hold its gaze steady on a single star for hours at a time, immune to the tiny tremors of solar radiation, the flexure of metal and glass as temperatures shift. The sun shield, with its 5 membrane-thin layers, must keep the instruments cool and dark, lest the heat of the telescope itself masquerade as a signal from the cosmos. Every observation is a feat of patience and precision, a slow gathering of photons from the edge of time. The history of Webb's creation is itself a testament to the difficulty and daring of this endeavor. Early designs called for a smaller mirror, a simpler sun shield, a quicker launch. But as ambitions grew, so too did the engineering challenges. Each mirror segment had to be ground and polished to nanometer precision. The sun shield's 5 layers had to be folded and stowed, then unfurled in the vacuum of space, each one perfectly aligned. The instruments, assembled by teams across continents, had to survive the violence of launch and then awaken, piece by piece, in the cold silence beyond the moon. There were delays, setbacks, moments of doubt. Budgets swelled, timelines slipped, and critics questioned whether so complex a machine could ever fly. But the vision endured, fueled by the promise of discoveries undreamt of. At last, in the winter dawn of December 2021, Webb soared skyward atop a column of flame, folded tightly in the nose of an Ariane 5 rocket. For weeks, engineers and astronomers watched with bated breath as the telescope unfolded itself in space, sun shield first, then mirrors, then the delicate dance of focus and alignment. Now, with its instruments cooled and its optics tuned, Webb is at work, gathering the faintest whispers from the birth of time. Its data is not simply a collection of images, but a map of the universe's hidden heat, a record of ancient chemistry and cosmic architecture. Each observation is a puzzle piece fitted into the grand mosaic of cosmic history. Yet the most wondrous aspect of Webb may be the way it brings together so many frontiers of science. With NERCam, we peer back to the first glimmers of structure, the dawn-lit galaxies assembling in the universe's youth. With MIRI, we probe the cold, dusty cradles of planet formation, the icy mantles of comets, the chemical complexity of interstellar space. Through spectroscopy, we decode the atmospheres of worlds beyond our sun, searching for the familiar breath of water and the strange perfumes of alien chemistry. Webb's clever experiments extend farther still. With its exquisite sensitivity and resolution, it can monitor the flickers and flares of variable stars, trace the growth of black holes, map the spiral arms of galaxies twisting through cosmic time. It can catch the afterglow of supernovae, the faint echoes of gravitational waves, the fleeting shadows of comets passing before distant suns. Each experiment is a dialogue between human curiosity and the cosmos, a question inscribed in the language of light and answered by the universe's own hand. The telescope's vantage at L2, always in the shadow of the sun, means it can observe for weeks or months at a stretch, building up images and spectra of stunning depth and clarity. Unlike Hubble, which must dodge the glow of Earth and Moon, Webb is free to gaze uninterrupted, plumbing the darkness for hidden wonders. This stability and freedom give rise to new kinds of surveys, deep fields that reveal thousands of galaxies in a single patch of sky, time-lapse observations that capture the evolution of distant objects, coordinated campaigns that link Webb's vision with that of ground-based telescopes and other observatories in orbit. Yet, for all its sophistication, Webb is not the end of the story, but a beginning, a new chapter in humanity's ongoing search for understanding. The instruments aboard are tools, exquisitely crafted and tuned, but they are guided by questions as old as stargazing itself. Where did we come from? How did the first stars ignite? Are we alone in the vastness? Each answer Webb provides will open new avenues of inquiry, new mysteries to pursue. As the telescope continues its patient vigil, collecting the ancient glow of galaxies and the fleeting shadows of planets, it invites us to ponder what lies yet unseen, what secrets may be revealed in the next sliver of darkness, the next spectrum unravelled, the next world glimpsed in the faint warmth of its star. The story of Webb is far from finished. Its golden eye is still opening, still adjusting to the infinite complexity of the cosmos. And as it gathers light from the edge of time, another chapter waits in the wings, a tale of data, of discovery, of the profound questions that arise when we finally hold the universe's secrets in our hands and listen for what they may whisper in reply. In the hush of the deep night, when the world quiets and the sky stretches vast and unblinking above us, the James Webb Space Telescope hangs in the darkness, silent and tireless, keeping its lone vigil. Suspended at the delicate balance of Lagrange Point 2, nearly 1.5 million kilometers from the warmth and bustle of Earth, Webb is more than a machine. It is an emissary, an extension of human curiosity, a whisper of wonder cast into the ancient darkness. All around it, space is cold, 3 degrees above absolute zero, yet from this frigid citadel, Webb's golden mirrors glow softly with the light of distant suns, gathering stories in the form of photons that have journeyed across eons to reach its waiting senses. Let us dwell for a while within this moment, as one might linger on the threshold of a vast and unlit cathedral, eyes adjusting to the grandeur, heart swelling with the quiet of possibility. Webb is not simply a telescope, it is a question made physical. It asks with every exposure, every unfurled mirror, every whisper of data, who are we here in the darkness? What is this universe that bore us, and what secrets lie hidden beyond the reach of our eyes? The act of building such a machine is itself an act of hope. For decades, hundreds upon hundreds of minds, engineers, astronomers, programmers, machinists, dreamers, labored to shape Webb. Its mirrors are coated with gold so thin that a stack of them would barely rise above the breadth of a human hair, yet they must catch the faintest warmth from stars born before Earth itself existed. Its sun shield is a marvel of engineering, 5 layers thinner than paper, stretched out as a shield against the fierce daylight of the sun, so Webb's instruments might drink in the feeblest embers of the first galaxies. Every rivet, every microchip, every rivulet of solder is the product of intention, ingenuity, and above all, perseverance. Yet as the telescope takes its first images, as data streams down from orbit in fragile signals that must be coaxed and corrected, the meaning of Webb transcends its physical form. It represents the deep-seated longing of humanity to know itself and its place in the cosmos. This longing is older than writing, older than cities, older perhaps than language itself. It is carved into the bones of our ancestors who gazed up at the unfamiliar constellations in a world unmarked by city lights, who wondered at the shifting stars and the waxing moon, who told stories to make sense of the patterns overhead. But Webb is the latest chapter in a saga of exploration that began with firelight and questions. It is a story drawn forward by the gravity of wonder, by the unshakable belief that, by looking outward, we come to understand something essential about ourselves. With each new telescope, from Galileo's crude glass to Hubble's orbiting eye, our vision has grown sharper, our questions more refined, our place in the universe both humbled and ennobled. Webb's mission is one of profound humility. Its instruments are tuned not to the brightness of the nearby, but to the faintest whispers from the edge of time itself. It peers into wavelengths invisible to the naked eye, into the cool infrared where the earliest galaxies glow like embers in the ashes of creation. Its detectors can sense the gentle warmth of planets orbiting distant suns, the chemical signatures of water, carbon dioxide and methane, potential hints of life, however humble, on worlds unimaginably remote. It is as though we have pressed our ear to the vastness and are listening for an echo of ourselves. What then does Webb's whisper mean for us, gathered here on this blue-green world, turning slowly beneath the telescope's distant gaze? Perhaps most immediately it means that we are not content with ignorance. The questions Webb explores are not the idle curiosities of comfort, but the urgent existential puzzles that have haunted us since the beginning. How did the first stars ignite? What shaped the galaxies into their spiral and elliptical dances? Are we, in our solitude, unique, or is life a common refrain, sung by the universe in 1,000 variations? Webb's observations are, at once, a search for origins and an act of remembrance. As it looks deeper into space, it looks further back in time. The light it receives set out on its journey billions of years ago, before our sun was born, before the earth coalesced from dust and gas, before even the heavy elements in our bodies were forged in the hearts of ancient, dying stars. To gaze through Webb's eyes is to see the universe as it was, not as it is, to witness a cosmic memory preserved in the language of light. There is a strange comfort in this, a kind of cosmic kinship. The atoms that make up our bones and blood were once part of stars that lived and died long before life began on Earth. The same processes Webb now observes in distant galaxies, gravity drawing gas into stars, fusion forging new elements, supernovae scattering the seeds of planets, are the very processes that made our own existence possible. In this sense, Webb's mission is not only scientific but ancestral. It is an act of remembering, of tracing our lineage beyond history, beyond biology, into the physics of creation itself. Yet, for all its power, Webb also reminds us of our limitations. The universe is vast beyond comprehension, and most of it will remain forever out of reach. Even the light from the most distant galaxies has been stretched and dimmed by the expansion of space, redshifted beyond the grasp of any conceivable detector. There are mysteries that will endure, horizons we can approach but never cross. In the face of such enormity, Webb's achievements are both triumphant and humble. Each discovery is a small clearing in the forest of the unknown, a momentary patch of understanding surrounded on all sides by deeper, darker woods. This humility is not a defeat, but a gift. It teaches us to be patient, to listen carefully, to accept uncertainty as part of the human condition. The questions Webb raises about the nature of time, the fate of the universe, the possibility of life, are not puzzles to be solved once and for all, but invitations to wonder, to keep asking, to keep searching. In this way, Webb is not only a tool for astronomers, but a teacher for us all. The philosophical implications of Webb's mission are as profound as its scientific ones. To peer so far into the past is to confront the fleetingness of our own existence. Civilizations rise and fall, languages change, continents drift, yet the universe endures. The galaxies Webb reveals are ancient and unchanging on human timescales, yet they too are born, grow old and dissolve. Against this backdrop, our lives might seem insignificant, brief sparks in a vast, indifferent night. But there is another way to see it. The very fact that we can build a telescope like Webb, that we can ponder the origins of everything, is a kind of miracle. Out of the chaos of chemistry and chance, a planet formed where consciousness could arise, where atoms could learn to wonder about themselves. Webb is a symbol of that wonder, a monument to the improbable fact of our own awareness. In the patterns of light captured by Webb, we glimpse not only the history of the cosmos, but the potential futures of humanity. What will it mean if we find worlds with atmospheres like our own, with the faint chemical traces of life? What will it mean if we do not? Will we feel more alone or more connected, more isolated or more at home in the universe? These questions are not merely scientific, they are deeply human, woven into our sense of self and story. Webb's discoveries will shape our myths as much as our models, our poetry as much as our physics. The images it returns, of galaxies colliding, of stars enfolded in cocoons of gas and dust, of planets swathed in alien atmospheres, will become part of our shared imagination. They will inspire new generations to ask new questions, to build new instruments, to reach ever further into the unknown. In this way, Webb is both a culmination and a beginning, a bridge between what we have learned and what we have yet to discover. Consider for a moment the deep symbolism of sending such a delicate, intricate machine so far from home. Webb is not protected by the magnetic field of Earth, nor easily reached by human hands. It operates in an environment as harsh and unforgiving as any in the solar system, dependent on the precision of its construction and the ingenuity of its creators. In every sense, it is vulnerable, yet it persists, gathering data, expanding our vision, carrying our questions into the deep. This vulnerability is not a flaw, but a mirror held up to ourselves. We too are fragile, and our journey is perilous. Yet, like Webb, we reach outward, we endure, we hope. There is an old saying that to understand is to forgive. In the context of the cosmos, perhaps to understand is also to belong. Webb's mission is not only to map the heavens, but to help us find our place within them. As we unravel the history of galaxies, the birth of stars, the chemistry of distant worlds, we are also constructing a new story of ourselves, a story in which humanity is both a product of the universe and a participant in its ongoing drama. In the quiet hours of the night, when the world is still and the stars are sharp, one might look up and remember that, far beyond the reach of any mountaintop, the James Webb Space Telescope is at work. Its golden mirrors are turned outward, but its mission is always, in some sense, turned inward. It asks what it means to be conscious in a universe that is vast and ancient and full of mysteries. It asks whether, in searching the stars, we might come to know ourselves a little better. The answers Webb finds will not be final. They will not close the book on our curiosity. Rather, they will open new chapters, new avenues for wonder and exploration. Each discovery will seed new questions. Each image will challenge old assumptions. Each spectrum will hint at deeper complexities. This is the nature of science and of humanity itself, a never-ending dialogue between what is known and what is possible, between the finite and the infinite. As we await the next data drop, the next image, the next subtle signature in the light, there is a sense of anticipation, a collective holding of breath, but there is also a sense of continuity. Webb's mission is part of a lineage that stretches back through Hubble, through the great observatories of the 20th century, through the first astronomers who marked the rising of the stars on stone. It is part of a lineage that will endure as long as there are minds to wonder and hands to build. In the end, perhaps the greatest gift of Webb is not any particular discovery, but the act of searching itself. To send a telescope so far, to tune it to the faintest whispers of the cosmos, is an affirmation of our capacity for wonder, our refusal to accept the boundaries of what is known. It is a reminder that even in the face of uncertainty, we are capable of reaching for the stars. So the Webb Space Telescope continues its silent vigil, gathering light from the furthest reaches, whispering stories to those who listen. Its data will be pored over by scientists and dreamers alike. Its images will adorn books and screens and the walls of classrooms. Its legacy will shape the questions we ask about ourselves and our universe. And as we listen to its whisper, soft, persistent, full of longing, we are reminded that the search for understanding is, itself, a kind of homecoming. The universe is vast and strange, but through the lens of Webb it becomes a little more familiar, a little more our own, even as it beckons us onward toward deeper mysteries and the promise of discovery yet to come. As our journey with the James Webb Space Telescope drifts gently to a close, like a comet tail fading into the hush of space, may your thoughts wander softly among the stars it reveals. Rest easy beneath the vast cosmic quilt, and return soon for more Dreamtime tales that whisper the universe's sweetest mysteries.